The most terrifying disasters are the ones that happen in total silence, until the final second. A metal fatigue crack, a loosening bolt, a shifting foundation. They wait for years for the perfect moment to strike. Tonight we witness the end of 6 lives that were extinguished by the very objects designed to serve them. Watch closely. The world around you is heavier, sharper, and faster than you think. October 14, 2004, Interstate 40, just outside of Knoxville, Tennessee. The time is 3:17 a.m., a graveyard hour where the rhythm of the highway shifts from the erratic flow of commuter cars to the heavy, industrial thrum of long-haul logistics. The Blue Ridge Motor Inn sat exactly 60 feet from the breakdown lane, a proximity that was legal but psychologically dangerous. Inside room 108, 39-year-old logistics coordinator David Miller was deep in the 3rd cycle of REM sleep, entirely unaware that his choice of a budget motel had placed him directly in the path of a kinetic anomaly. David was a man of routine. He had checked the door lock twice, set his alarm for 6:00 a.m., and placed his phone on the nightstand, expecting a standard night of rest before a morning meeting. The room was standard, beige wallpaper, the hum of a through-the-wall air conditioning unit, and a single window covered by thick, light-blocking curtains. However, the most critical element of room 108 was not the furniture, but the construction of the exterior wall facing the highway. Built in the late 1970s during a rush to accommodate travelers, the motel developers had utilized hollow concrete masonry units, standard cinder blocks, without reinforcing steel rebar or solid concrete grout filling the cavities. To the naked eye, the wall appeared to be a solid fortress of stone, but in terms of structural engineering, it was a rigid grid of air pockets with very low shear strength. While David slept, a physical crisis was unfolding 3 miles up the highway grade. A fully loaded 1999 Freightliner Century class, hauling 42 tons of rolled steel coils, was descending the slope. The driver, fighting a tight delivery window and exhaustion, had been riding the brake pedal for the last 2 miles, a fatal error in heavy transport. Inside the wheel hubs, the brake drums had exceeded their thermal limit, glowing a dull, angry cherry red. This triggered a mechanical phenomenon known as brake fade. Essentially, the intense heat caused the chemical resin in the brake pads to vaporize, creating a microscopic layer of hot gas between the pad and the drum. Friction dropped to 0. The driver pressed the pedal to the floor, but the truck did not slow down. It accelerated. Gravity took control of the 80,000-pound mass, turning the vehicle into an unguided projectile moving at 75 miles per hour. The physics of this moment were absolute. The truck was no longer a vehicle. It was a kinetic weapon carrying roughly 35 million joules of energy. As the rig drifted across the rumble strips, the driver fought the steering wheel, but the momentum of the shifting steel coils in the trailer pushed the cab sideways. David Miller did not hear the terrified blast of the air horn or the screech of tires scrubbing uselessly against the asphalt. The sound of the approaching disaster was masked by the white noise of his own air conditioner. At the precise moment of impact, the difference between a reinforced wall and a hollow wall became the difference between survival and oblivion. When the chrome bumper of the Freightliner struck the exterior of room 108, the cinder blocks did not absorb the energy, they shattered. Because the blocks were hollow and unreinforced, they lacked the tensile strength to flex or deflect the blow. The wall simply disintegrated into an explosive burst of concrete, shrapnel, and dust. The truck did not stop at the facade. It plowed through the masonry with the ease of a hand pushing through water, carrying the entire front section of the building into the room. The event occurred within a time frame that is biologically impossible to react to. The human brain requires approximately 200 milliseconds to process an auditory threat and another 100 milliseconds to trigger a motor reflex. The collapse of the wall and the intrusion of the truck cab happened in less than half that time. David never woke up. He never felt fear, panic, or pain. The impact delivered catastrophic, blunt force trauma to his sleeping form instantly, causing immediate and fatal trauma before his neural synapses could even register the sound of crashing glass. It was a clinical, instantaneous termination of consciousness caused by massive structural displacement. The truck finally came to a halt with its front axle resting where the bathroom sink had been, the cab buried under a mountain of drywall, twisted bed frame, and pulverized concrete. Steam hissed from the ruptured radiator, mixing with the thick, gray cloud of masonry dust that now filled the air. In the immediate aftermath, the silence was heavy, broken only by the settling of debris and the distant, confused shouting of other motel guests. First responders arrived within 8 minutes, but the scene was a recovery operation, not a rescue. Firefighters found that the engine block of the truck was still radiating immense heat, sitting just feet from where the headboard of the bed had been. The investigation that followed revealed the terrifying simplicity of the tragedy. Had the wall been constructed of reinforced concrete or solid-filled blocks, it likely would have deflected the cab or absorbed enough kinetic energy to leave a survival void, a triangular space of safety amidst the wreckage. Instead, the hollow blocks had failed catastrophically, offering no more resistance than glass. David Miller had done everything right that night. He was a responsible man sleeping in a legal establishment. His death was not a result of his own error, but a consequence of cost-cutting construction meeting the unforgiving laws of motion. It stands as a brutal reminder that safety is often an illusion provided by cheap materials, and when mass meets a hollow structure, the outcome is never a negotiation. It is a mathematical certainty. July 12, 1998, El Paso, Texas. The evening air was a thick, stagnant blanket of desert heat that smelled of dry asphalt and ozone. At the Desert Rose Motel, a weathered relic of the 1950s, the primary landmark was a 50-foot-tall neon sign that stood as a glowing beacon of pink and turquoise light. This massive steel structure, weighing nearly 6,000 pounds, was positioned on a towering pylon that leaned slightly over the front row of rooms. Inside room 212, directly beneath the shadow of this monument, 32-year-old Rebecca Vaughn was lying on her bed. She was a solo traveler who had chosen this motel specifically for its vintage charm. She had just finished a phone call with her family, unaware that the very icon she had admired upon arrival was currently undergoing a terminal mechanical failure. The room felt solid, but the ceiling above her was a lightweight assembly of plywood, thin insulation, and asphalt shingles. It was designed to repel rain, not to withstand the vertical impact of industrial steel. Outside, the weather was shifting rapidly as a severe thunderstorm rolled across the desert. Wind gusts began to peak at 75 miles per hour, slamming into the broad, flat face of the neon sign. This environmental stress was interacting with a hidden defect known as metal fatigue. To understand this, imagine bending a paperclip back and forth. Eventually, the metal grows hot, weakens, and snaps. For 40 years, the Texas wind had been bending the steel pylon of the sign in exactly the same way. Microscopic cracks had formed at the base welds, hidden under layers of old paint and decorative trim. Rainwater had seeped into the hollow core of the support beam over decades, causing internal corrosion that ate away at the structural integrity from the inside out. To a passerby, the sign looked permanent, but the steel was now a brittle, rusted shell. At 9:42 p.m., a powerful gust of wind acted like a lever against the sign's massive surface area. The metal reached its breaking point. The pylon did not bend. It underwent a total structural failure. A deafening metallic crack echoed across the parking lot as the sign sheared off its base. In this moment, 3 tons of steel and glass became a free-falling mass. Gravity accelerated the object at 32 feet per second squared. Because the sign was top-heavy, it tilted as it fell, aiming the sharp corner of its heavy steel frame directly at the roof of room 212. The entire collapse took less than 2 seconds. Rebecca Vaughn had no warning. There was no time to hear a creak or see a shadow. The micro-hope of the sign missing the building vanished as the center of gravity aligned perfectly with the bed. When the sign struck the roof, the plywood offered zero resistance. The sign did not hit the building. It punched through it like a hammer through a cracker. The velocity and mass turned the ceiling into a spray of splinters and dust. The heavy angle iron frame crushed the bed into the floorboards instantly. The clinical result was a statement of physics. Sarah suffered catastrophic blunt force trauma to the upper body, resulting in the immediate termination of all neurological functions. The mechanical force was so great that it caused an instant loss of consciousness and cardiac arrest. There was no biological window for a pain response. The motel room was transformed into a chaotic heap of twisted metal and shattered neon tubes in a fraction of a heartbeat. After the impact, a strange silence returned to the site. One section of the neon tubing remained powered for several minutes, flickering and buzzing with a ghostly pink light amidst the ruins. Outside, the wind continued to howl, but the towering landmark was gone, replaced by a jagged stump of rusted iron. Emergency responders arrived to find the heavy sign wedged so deeply into the foundation that they required a heavy-duty crane to begin the recovery process. The subsequent investigation by structural forensic experts confirmed that the metal fatigue had reduced the support beams to less than 20% of their original thickness. It was a fatal lesson in the decay of infrastructure. The sign had stood for 40 years, creating an illusion of safety while moisture was slowly dismantling its core. Rebecca Vaughn had sought shelter under a landmark she trusted, never realizing that the heavy history above her head was waiting for one final breath of wind to turn a nostalgic icon into a 3-ton falling weight. The world moved on, and the motel was eventually demolished, but the event led to new, stricter inspection laws for vintage signage across the state. The only thing left of Sarah's night was a half-finished book on the floor, now buried under a shard of pink glass, marking the exact spot where the laws of physics and human life collided for the final time. November 12, 2012. The Grandview Suites in downtown Chicago was a dual reality. Above ground, it was a world of plush carpets and silent corridors, but 3 levels below the lobby lay the heart of the house, a subterranean labyrinth of concrete, high-voltage conduits, and steam pipes. This was the domain of logistics, not guess, a place where the hotel processed 4 tons of laundry every 24 hours. At 2:45 a.m., 28-year-old software developer Michael Sterling crossed the invisible line between these two worlds. Jet-lagged after a cross-country flight and severely dehydrated, Michael left his room on the 4th floor in search of a vending machine or an ice dispenser. Disoriented by fatigue and the identical beige hallways, he took a service elevator by mistake, descending into the basement instead of the lobby. The service door, which should have been secured by a magnetic keycard lock, had been propped open with a rubber wedge by a night porter to facilitate the movement of linen carts. Michael stepped into the industrial laundry facility, a cavernous room filled with the roar of heavy machinery and the sharp chemical scent of industrial bleach and ozone. The room was dominated by a row of massive, stainless steel hydro-extractors, industrial centrifuges designed to spin wet linens at high velocities to remove water before drying. The machine at the end of the row, Unit 4, was in the middle of a high-speed extraction cycle. Its internal stainless steel drum was rotating at 1,200 revolutions per minute. At this speed, the outer edge of the drum was moving at over 100 miles per hour, generating a centrifugal force hundreds of times stronger than gravity. Under federal safety regulations, this machine is designed to be a sealed vault. A fail-safe electromagnetic interlock system prevents the heavy steel lid from being opened even a fraction of an inch while the drum is in motion. However, the laundry staff had been battling a faulty sensor on Unit 4 for weeks. To keep up with the relentless demand for clean towels, a maintenance worker had bypassed the safety solenoid, using a simple plastic zip tie to trick the computer into thinking the lid was locked when it was actually unlatched and vibrating slightly ajar. This act of negligence transformed a cleaning appliance into a kinetic trap. Michael, confused by the noise and heat, stepped closer to the vibrating machine, likely assuming it was a large ice maker or simply trying to read the digital display to find his bearings. He was wearing an oversized, heavy cotton-hooded sweatshirt against the autumn chill, a garment that would soon become the primary instrument of the tragedy. As he leaned forward, the long, dangling drawstring of his hoodie swung into the narrow gap between the stationary housing and the spinning basket. The capture was instantaneous. The friction of the spinning drum snagged the cord, and the rotational torque of the 50-horsepower electric motor was applied directly to the garment. The physics of the interaction were immediate and overwhelming. A human being cannot react faster than a machine spinning at 20 revolutions per second. Before Michael could even gasp, the drawstring was wound around the spindle like a winch, pulling his upper body violently toward the steel casing. The hooded sweatshirt did not tear. Instead, it acted as a constricting steel cable. The force pulled him down and forward with the energy of a car crash. His head and torso were slammed against the rigid steel rim of the machine with catastrophic velocity. The motor did not stall. The resistance offered by a human body was negligible compared to the torque required to spin 200 pounds of wet denim. The machine continued to rotate, tightening the fabric until the pressure on Michael's neck and chest exceeded the structural limits of his anatomy. The compression was absolute. He was pinned against the vibrating metal, unable to breathe, unable to move, and unable to scream. The trauma was a combination of severe blunt force injury from the initial impact and rapid mechanical asphyxia caused by the tightening garment. The isolation of the laundry room meant that the struggle occurred in a vacuum of noise. The roar of the extractor masked the sound of the impact completely. The machine eventually completed its cycle 8 minutes later, spinning down to a halt as if it had performed a routine task. Michael was discovered 40 minutes later by a night shift worker who came to transfer the load. The forensic analysis of the scene was a grim lesson in the consequences of bypassing safety protocols. The lockout-tagout procedure exists for a reason. Industrial kinetic energy does not distinguish between a wet towel and a human being. The zip tie on the sensor was a shortcut that saved the staff perhaps 10 seconds of effort, but it cost a guest his future. The investigation revealed that the machine had been operating in this unsafe condition for over a month, a latent variable waiting for the precise moment when a loose string in a tired stranger would intersect. Michael Sterling's death was not an accident in the traditional sense. It was the inevitable mathematical result of introducing a soft, biological organism to a high-velocity mechanical system that had been stripped of its only conscience, the safety switch. It serves as a terrifying reminder that in the presence of industrial torque, loose clothing is not just fashion, it is a potential anchor that can drag you into a world where physics has no mercy. The Sierra Sands Extended Stay Motel in Reno, Nevada was a relic of a bygone era, a budget accommodation designed for maximum efficiency, not comfort. The rooms were architectural puzzles, cramped spaces where every square foot was monetized, and the centerpiece of room 204 was a Murphy bed, a wall-mounted sleeping apparatus designed to fold vertically into a cabinet to save floor space during the day. For 34-year-old freelance graphic designer Elena Rostova, the room was simply a cheap place to work and sleep while attending a digital arts convention. Elena was a creature of habit. She preferred to utilize the open floor space for her morning stretching routine and to organize her portfolio, treating the room as a temporary studio. At 8:15 a.m., she was lying on the thin, industrial-grade carpet, positioned directly in the footprint of the retracted bed, utilizing the empty space that the folded mechanism provided. The room was silent, save for the rhythmic humming of the refrigerator and the distant traffic of the interstate. However, directly above her head, a silent mechanical failure was reaching its critical point. The bed in room 204 was not a modern hydraulic-assisted unit. It was a heavy steel frame model installed in the late 1980s, relying on a set of powerful, high-tension steel coil springs to assist in lifting the mattress. These springs were under immense potential energy, constantly pulling against the wall anchors with hundreds of pounds of force. Over 3 decades, the lag bolts securing the heavy cabinet to the wall studs had been subjected to thousands of stress cycles, slowly pulverizing the dry wood around the threads. Simultaneously, the primary safety latch, a simple steel pin designed to keep the bed locked in the upright position, had suffered from severe metal fatigue, developing microfractures invisible to the naked eye. It was a binary system of safety. Either the latch held the 300-pound structure vertical, or gravity would claim it. At 8:17 a.m., a heavy delivery truck rumbled past the motel on the adjacent street, creating a subtle, low-frequency vibration that traveled through the foundation and up the walls of the building. This minor tremor was the final variable in a long-running equation of decay. The fatigue safety latch, unable to withstand the vibration, sheared off completely. Simultaneously, the top wall anchors, having lost their grip in the rotted wood, ripped free under the relentless tension of the springs. The result was catastrophic. The entire bed unit, a massive assembly of steel, particle board, and a queen-size mattress, did not just fall, it was effectively fired downward by gravity and the sudden, violent release of spring tension. The structure, weighing nearly 300 pounds, pivoted on its base and slammed into the floor with the speed and force of a falling heavy mass. Elena, positioned directly in the impact zone, had zero reaction time. The human brain requires a fraction of a second to process a visual or auditory threat, but the bed covered the vertical distance in less time than it takes to blink. The heavy steel frame struck her across the upper torso and neck, pinning her instantly against the concrete slab beneath the carpet. The mechanics of the injury were not caused by the impact alone, but by the relentless, crushing weight that followed. The medical term for the event is traumatic asphyxia. The sheer mass of the bed compressed her chest wall, making it mechanically impossible for her diaphragm to contract and her lungs to inflate. She was trapped in a rigid cage of steel and wood, fully conscious for a few terrifying seconds but unable to draw a single breath. The room remained terrifyingly silent. The bed now looked like it was simply in the down position, completely concealing the tragedy beneath it. Because the heavy cabinet had detached from the wall, it added extra dead weight to the frame, sealing the trap. Elena's struggle was brief. Without oxygen, consciousness fades within seconds, followed by cardiac arrest. There was no scream, no chance to lift the weight, and no way to signal for help. She was discovered 6 hours later by housekeeping staff who, assuming the guest was still sleeping, tried to wake her, only to realize the bed was not resting on the floor, but on a person. The forensic investigation revealed that the mounting bolts had been installed into drywall rather than structural studs, a construction error that had held for 30 years before finally surrendering to physics. The tragedy serves as a brutal lesson in the dangers of stored energy and concealed wear. A Murphy bed is not just furniture, it is a heavy machine held in place by a small piece of metal, and when that metal fails, the floor becomes a kill zone. August 5th, 2016, the Sea Breeze Inn in Galveston, Texas, was a product of the coastal tourism boom of the 1960s, a two-story structure built for function, not longevity. Its most defining feature was the exterior walkway balcony that wrapped around the second floor, a common architectural choice for seaside motels that exposes the building's skeleton to the relentless assault of salt, sun, and humidity. For 26-year-old Sarah Jenkins, the motel was just a place to sleep after a long day of celebrating her friend's bachelorette party. At 11:30 p.m., she stepped out of room 212 and onto the concrete balcony, leaning against the iron railing to take a phone call. The night air was thick and humid, carrying the distant sound of waves and the faint, corrosive smell of the ocean. Sarah was in a state of relaxed euphoria, her mind on the wedding plans, completely unaware that she was standing on a structural time bomb. Concrete, to the human eye, appears to be a permanent, monolithic stone. In reality, it is a porous material, and the concrete used in the Sea Breeze Inn was a cheap, low-density mix. Its real strength came from the hidden network of steel reinforcing bars, or rebar, embedded within it. This rebar is the true skeleton of the structure, but it has a fatal weakness: rust. For over 50 years, humid, salt-saturated air had seeped into the microscopic pores of the balcony slab, initiating a slow, invisible chemical reaction. The salt acted as a catalyst, accelerating the corrosion of the internal rebar. As the steel rusted, it expanded to more than 4 times its original volume, a process known as rust jacking. This expansion created immense internal pressure, causing microfractures within the concrete, which in turn allowed more moisture to penetrate, accelerating the decay in a vicious cycle. The rebar that was supposed to anchor the balcony slab to the main building had been reduced to a fragile, flaky shell of its former self, its tensile strength virtually non-existent. From the outside, the balcony looked fine, save for a few cosmetic cracks and some rust stains that had been painted over during routine maintenance. The structural integrity, however, was a lie. Sarah, weighing approximately 130 pounds, was not a significant load, but her presence on the outer edge of the slab created a lever effect, placing the maximum tension on the already compromised upper rebar connections. The final variable was a sudden gust of wind from an approaching storm, which added a small but critical dynamic load to the structure. At 11:32 p.m., the last remaining strands of corroded steel connecting the balcony section to the building reached their breaking point and snapped. The failure was not a slow crumble, it was an instantaneous, catastrophic fracture. The entire 10-foot-long, 4-ton slab of concrete Sarah was standing on detached from the building as a single massive piece. There was no warning, no creak, no groan. In one moment, she was standing on solid ground. In the next, the ground disappeared from beneath her feet. The slab tilted forward and dropped, not as a controlled descent, but as an accelerating stone slab. Sarah fell with the slab, a 12-foot drop onto the concrete walkway below. The physics of the event were brutal and absolute. A human body falling 12 feet reaches a speed of nearly 20 miles per hour. The initial impact with the ground was severe, but the secondary event was the true mechanism of fatality. The 4-ton concrete slab landed a fraction of a second after her, impacting the ground with an energy equivalent to a small car crash. The slab did not just fall, it crushed the space where she landed. The outcome was instantaneously fatal, with catastrophic compression injuries inflicted across the entire body. The sound of the impact was like a controlled demolition, a deep, earth-shaking boom that echoed through the motel courtyard, followed by the tinkle of shattering glass from nearby windows. Guests poured out of their rooms to find a scene of architectural carnage, a gaping hole in the second-floor walkway, and a massive fractured slab of concrete lying on the ground floor, half buried in the soft lawn. The investigation that followed was a grim autopsy of neglect. Engineers found that the rebar had corroded to the point where it could be crumbled by hand. The motel's maintenance records showed no history of structural inspections, only routine painting and patching that concealed the terminal decay. The tragedy of Sarah Jenkins was a direct result of ignoring the slow, relentless power of chemistry. She was a victim not of a freak accident, but of a predictable failure that had been developing for decades. Her death serves as a terrifying reminder that the most solid-looking structures can be hollowed out by invisible forces, and that gravity is always waiting to reclaim what rust has weakened. May 20, 2013. The third-floor hallway of the Midway Plaza Hotel in Des Moines, Iowa, was a generic, liminal space of beige carpets and humming fluorescent lights, a place meant to be passed through, not experienced. Near the ice machine stood a brightly lit soda vending machine, a beacon of modern convenience. For 19-year-old college student Kevin Price, this machine was the final obstacle on a late-night quest for a caffeine fix to fuel an all-night study session for his impending physics final. At 1:40 a.m., he inserted 2 wrinkled dollar bills into the machine, selected a can of voltage dew, and waited. The machine whirred, the selection coil rotated, but the can remained stubbornly lodged in its spiral track, a common and infuriating malfunction. Kevin was a man of logic and reason, a student of the very laws that were about to kill him. Yet in this moment, his rational mind was overridden by a primal, human frustration. His goal was simple: retrieve the soda he had paid for. The vending machine, a standard Royal Vendors G-Snack model, was an inanimate object, but it was also a fortress of steel and glass, weighing approximately 850 pounds when fully stocked. Its engineering was designed for security, not mobility. However, its most critical physical attribute was its high center of gravity. The heavy refrigeration unit and the bulk of the soda cans were located in the upper 2/3 of the machine, while the base was comparatively light, making it dangerously top-heavy. This design created a significant tipping hazard, a fact noted in a small, often ignored warning label near the coin slot. After a few unsuccessful attempts to reach up into the dispensing chute, Kevin's frustration escalated into a physical confrontation. He grabbed the sides of the machine and began to rock it back and forth, attempting to use momentum to dislodge the trapped can. The first few shakes were tentative, but as the can refused to budge, his efforts became more aggressive. He was applying the principles of leverage and force, but he had critically miscalculated the physics of the machine's stability. With each rock, the machine tilted further, its base lifting slightly off the carpet. Kevin was so focused on the can that he failed to notice the point of no return. As he gave one final, powerful heave, he pushed the machine's center of gravity past the edge of its base. This was the critical moment where stability becomes an impossibility, and the laws of physics delivered their verdict. The machine did not just fall, it accelerated downward with the full, unforgiving force of its 850-pound mass. Kevin had a fraction of a second to realize his mistake, but human reflexes are no match for the speed of gravity. His eyes widened in a moment of pure, sudden understanding, but it was too late to jump back. The massive steel box slammed into him, pinning him instantly against the floor. The primary mechanism of the fatal injury was compressive asphyxia. The sheer weight of the machine on his chest and abdomen was immense, far exceeding the structural capacity of the human rib cage and making it impossible for his lungs to expand. He was trapped under an immovable object, the very thing he was trying to conquer. The impact was deafening in the silent hallway, a heavy percussive boom followed by the sound of shattering glass as the front panel cracked and soda cans spilled across the carpet. The machine that had refused to give him one can had now given him all of them. The irony was as brutal as the physics. His roommate, awakened by the crash, found him seconds later, but there was nothing to be done. It would take 4 firefighters to lift the machine off his body. The investigation that followed was short and simple. The cause of death was not a malfunction or a structural failure, but a direct, predictable consequence of a human underestimating the power of a simple machine. Kevin Price had spent his semester studying the laws of mass, momentum, and gravity. In his final moments, he received a practical, lethal lesson in all three. The tragedy is a stark illustration of a common cognitive bias, the belief that we can physically dominate the inanimate objects in our world. It serves as a grim reminder that an 800-pound steel box has no ego, no frustration, and no mercy. It only has mass, and when that mass is set in motion, it will always obey the laws of physics, even if the person who set it in motion does not. These victims walked into their rooms and felt nothing. No warning, no cold chill, just the routine of a normal day. It makes you wonder about your own instincts. Have you ever walked into a place, a hotel, a building, a strange room, and felt a sudden, inexplicable urge to leave immediately? That gut feeling might be the only survival tool you have. Tell me in the comments, what is the one place that gave you a bad vibe for no reason? If you trust your gut, subscribe now.